So we have another small update about the Pathfinder system here. As I mentioned in my last video, which nobody watched, except I guess at least two people watched because I got two comments. One from PunkGB, so shout out to you, and one from my friend who pretends to care, but I don't think he really does. Anywho, what I had said is that I will be adding sort of escape nodes on top of the spikes and all of the obstacles. So the enemies can sort of, if they're on the top of the spikes, they can sort of run off, or if they're inside of obstacles. So if these are obstacles that don't have a sort of solid collider like the spikes, you can walk through them. Like this is supposed to represent poisonous gas, by the way. I do not have an artist, so this display might not be the most interesting, but oh well. And I have added such a thing. So if we go to the path manager here and we open this and we debug the tester enemy, as you can see, we have now red nodes. So the way these escape nodes, as I call them, work, I just realized I haven't really described how the Pathfinder works. So first of all, you have these green nodes, which are the main nodes. This is what the agent, or in our case, the enemy, would always prefer to use. Now, if there's a really, long fall, sort of, if we end up here and the player is here and we're like, how are we going to follow them? There's no, sign connection, which means a connection downwards. And there's no jump down to a lower platform that we can do like here. Well, we can use these fallback nodes, as they're called, to connect downwards. Now, this connection seems like it goes in all directions, but each node is actually only allowed to connect downwards, so either straight downward or diagonally downwards. If you watched the previous video, you'd see that they actually could connect sideways. But I removed that because, for example, here, when the enemy doesn't want to walk on spikes, it tries to connect like this, sort of, and just does a straight connection here, and that's like not really a feasible thing for the agent to complete such a path. So I made it not able to connect sideways, except for certain situations where it connects to a primary node, or the primary node connects to it. So that's why we have the fallback nodes. The fallback nodes cannot generate jumps. You can only jump from a primary node to another. And now we have these red things, which were the main point of this video, which are the escape nodes. So essentially, the agent's actually never allowed to use these unless they themselves are within, an escape node. So if we're being chased from here and we, as a player, say the player has a more powerful jump or can double jump, so they go like this and then double jump again down here, the enemy cannot do that. So they're just gonna kind of just fall. And as you can see, they're gonna think they can follow the player. Well, technically they can't here, but assuming there were enough fallback nodes and they can catch a player, but they don't manage to follow that path perfectly, and they, for whatever reason, end up on the spikes. They can use these escape nodes to then pathfind out of the spikes onto primary nodes, or whichever, really. We have a system that basically finds the closest non-escape node that's the cheapest for the enemy. So I believe fallback nodes cost each connection here costs 2 points. Primary connection costs 1 point, and these cost 100 points. So they're really so the A-star method really tries to avoid them, avoid using these. And if the player is on the spikes and we are not on spikes, or not spikes, just any obstacle really, we cannot pathfind to the player. We start idling instead. We do not generate a valid path. So only if we and by we, I mean the agent, of course, could pathfind to the player, and both us and the player are on spikes. Can we pathfind to the player? But even then, we don't actually prioritize the player. We prioritize getting out of the spikes, so it's even smarter. Or if we ourselves are on spikes in general, we can pathfind out of them. And this is not only when we're chasing the player, but when we are idle as well. We can sort of just, you know, avoid being in obstacles, because those are supposed to be things that deal damage, so the enemy doesn't just kill itself, essentially. So if I disable this, because it is kind of noisy, and actually let's lower the detection range, because we don't want to be detected by the player. For now, we just want to test this by itself. And also, it has come to my attention that changing this cooldown, this is the cooldown that like keeps on counting uh, as long as we're not sort of kited to the player. If we're kited, it gets set to 0. Otherwise, it keeps on counting it. I suppose I could improve it a little bit, but that's not the point. Point is, it's going to always try to go back to its spawn position. So it's going to be harder to showcase if I don't put it to a crazy high number that we won't reach. So anyway, this is the enemy. As you can see, you can just drag it anywhere, whatever. When it's idling also, you can like see it's going to walk towards the gas, but it's gonna like, nope, I don't want to enter it. I'm going to, continue the other way. But now if we drop it here, as you can see, it just prioritizes pathfinding out as fast as possible. It does not want to be in these areas. Just like if we place it here, for example, in these spikes, it's going to want to just get out of there. And same here. Yeah, it just tries to get out of these spikes. Now, as you saw there, once it's no longer on them, it's going to like stop trying to pathfind. Could be kind of problematic in situations like this, where like it's supposed to go here, but then it falls somewhere else. But at that point, I feel like if I start accounting for such things, even I, as a perfectionist, especially when it comes to this system, because it's sort of like my baby, I don't think this is a necessary thing to try to change right now. So yeah, that's kind of all there is to it. It works perfectly fine. Let's see if we can make it chase the player. Let's see. Where were these numbers? Let's put this like on 150 and put this like on 50. So now we have detected the player, or we will detect the player because we're within the red, and we will always be in range sort of the, yeah. So as you can see, if we're on top of a spike, it can still pathfind because it actually checks for the closest node. But yeah, as you can see, it's not really problematic. But if we take the player, for example, here, where are you, enemy? There you are. So let's first actually put it like this. See, you cannot find a path because when it falls down, the fallback nodes only take it as far as here, and it just cannot reach. And see, it stopped idling here because it has a direct line of sight on the player. I also added that. Just like a nicer detail, like if you can't reach the player, it's gonna like stare them down. Unless like they're, actually unreachable, then it's gonna just start idling. But now if we put it, say, here, it can reach the player now because it can use the escape nodes. But as you see, it's gonna prioritize going away first. This is kind of a bad area to showcase it because It's not going to be able to chase the player after here because, well, we're in an unreachable position. But suppose the player, oh, sweet mercy. Suppose the player is here and we are here. So the closest path to the player is actually from here to here, just a straight path. But what you're going to see now is see it avoids it and it takes another path here and it's going to bug out a little bit here. Yep, that one is a different thing I need to work on. But it shouldn't be a problem at all. But yeah, so now we can actually perfectly avoid spikes. And if you're a person who just wanted to check up, I suppose you can click off the video now. But if you're quite interested, you can go into a little bit more detail on how the connections work. So even these can only connect diagonally. So the agent doesn't think, oh, I can just walk straight, because as you saw with our fallback connection example, sometimes you can just, or I didn't show the example, but I think you can. No, I don't even have it in the previous video. I don't have a screenshot of it either. You're just gonna have to take my word. So as I described it before, you used to just connect sort of from here and then from the left all the way to the right. And like, yeah, we can't have such a connection. It's just simply unrealistic. So I removed those, and for the same reason, they're not here. Except when it wants to connect to a fallback node. So we can actually have a way to escape. And if we are on the ground, they can connect purely horizontally as well. So we can have things such as here, or that other area where we can walk off the spikes. And yeah, I'd say that would be all. Now, there are some other things that I also worked on, but nothing really major. For example, this what the hell? Why is this not working? Interesting. Okay, so the issue simply was that I had zoomed out too much, so they weren't visible. But these are also the respawn positions. Now, because this system was going to be made like specifically for my project, I didn't think it's going to be such a big deal. And because it is such a big deal, I want to make this available for other people to use as well. I had implemented my respawn positions as a part of this pathfinding system as well, but they're kind of an arbitrary addition. The reason I added them from the beginning was because, well, every time I make change to the map, I would also want to regenerate the spawn positions as well as the navigational graphs for the enemies. But now I've separated it into its own thing, and therefore also kind of made the system a little bit better. But it's based on kind of the same logic as you can see here. You can have a list of objects you want to avoid, so we won't be placing respawn positions there. And yeah, as you saw, it takes, wait, let's try again. It takes 0.04 seconds almost to generate these respawn positions. So it's something really simple here, and it's really nice, and it works quite well. I don't think anyone's going to watch up to this point, so I'm not really going to bother with a showcase. But basically, if you die, it will pick one of these random positions within a certain range. And yeah, that would be all.